So as with equations, some equations have no solution or infinitely many. So no solution or infinitely many. That's why this is called the special systems. We're going to run across some that have no solutions and some that have infinitely many solutions. One way to tell how many solutions a system has is by inspecting its graph. So use the graph to solve this system of linear equations. So we have x plus y equals 7. So I'm just going to open up a tab in Desmos. We have the graph here. And so if I say x plus y equals 7, I believe that's this line. So that's probably going to be this line. And then it says 2x plus 2y equals 6. So that will cross at 3. So that's an interesting one because that one is this line. What do you notice about those two lines? They don't cross at all. So how many solutions do you think we're going to have? 0 solutions. So let's write that down. It says, is there a point of intersection, and explain. So you would say no. They appear to be parallel lines. Okay. And so what does that mean? Well, when they're parallel, there's no intersection. So let's scroll down and answer the next question. Does this linear system have a solution based on the graph? And the short answer is no. And you would say they, well, I'm going to word it a little fancier. They have no, they have no points in common. That's a fancy way of saying no intersection. So where the two lines intersect is a point in common. They both share that point. Okay. So now let's graph. Let's figure out if there's a point of intersection for these two lines. Now, here's an interesting one. I know that this line is this line, but guess what? Yeah, it's the same line. This line is the same line. So is there a point of intersection? Yeah, yes. Everywhere. And when we say everywhere, I'm going to specify on the line. It's not everywhere on the graph, it's everywhere in the line. Right? And so when we say that it has infinitely many solutions, we're not saying that it has, you can pick out any number for x and any number for y. The x comma y has to be on the line, right? It has to be here or it has to be here. But whatever point you have on the line, both equations share. So we say, does the linear system have a solution? Yes. And that's why we're using the word for all points in common. And you could say they are the same line. And then say they have infinitely, and I always misspell infinitely, infinitely many points in common. I said points in solution. That's not what I want to say. Points in common. Points in common. And any of those points are a solution. So I'm going to put right down here solutions. So if I find a point that they have in common, that is a solution to the system. So if I go back to the graph, so if I go back up here to the graph, and this is a point, that's a solution. Whatever that xy is, this is a solution. This is a solution. This point over here is not a point in common for both equations. So that's not a solution. It has to be a point in common. Does that make sense? I want to emphasize that because sometimes when you tell a kid it's infinitely many solutions, they're like, oh, well, anything will work. No. Just a point in common. Okay? So now it says reflect. Use the graph to identify two lines that represent a linear system with exactly one solution. So I'm going to zoom out a little bit. So what does that mean? You guys decide. There's a couple different answers. You choose one that works. Which one has exactly one solution? Huh? How about this equation, which represents this line, and this equation? So we could say 3x minus y equals 1. 3x minus y equals 1. And what was that other? X plus y equals 7. Has a solution at, I'm abbreviating the word solution. Where does it look like it crosses at right here? 2, 5. I'm going to write that in here. We'll say 2, 5. At 2, 5, or you could think of it like this: x equals 2, y equals 5. Okay? And then it says if each equation in the system has two linear equations, if each equation in a system of two linear equations is represented by a different line when graphed, what is the greatest number of solutions that you can have? One. Because if they're a different line, you can only have one solution. That's the greatest number. That's the greatest number. You could have no solution, but they would only intersect at one point if they're different lines. If they're the same lines, you'll have infinitely many solutions. But if it's two lines, they're going to cross somewhere. It doesn't matter how different they are. Even if they look like they're parallel, but they're not slightly, they'll intersect somewhere. So you'll have one solution. And then the next question is identify three possible solutions. Identify the three possible numbers of solutions for a system of linear equations. Explain each type of solution that occurs. Okay, so here's what I think they want us to say. One solution. I'm going to zoom in a little bit so you guys can see it in the back. One solution. Different lines. and then I'm going to say one intersection. They have one point in common, one intersection. The next one is no solution. Parallel lines. Parallel lines will not cross. And that's no points in common. That's an N, allegedly. And then lastly, we'll say infinitely many. They're the same line. Okay? And so let me give you an example of that. And speaking of abstract linear algebra, so if I go into Desmos, let me move my handsome face over here. If I say x plus y equals 4, I get a graph like that. Now, what if I take that whole equation and multiply it by 2? Well, then it would become 2x, yeah? 2x plus 2y equals, what's 4 times 2? 8. So when I finish this, guess what? Boom. 2 different equations, the exact same line. If I turn this off, they're the exact same line. So they have infinitely many solutions. Does that make sense? Okay. That's all I wanted to point out. Are there any questions? Oops, we're in here.